Hello everyone, glad you're joining us today. We'll be diving into a cool topic this time, CnosDB ecosystem integration, writing IoT data into CnosDB with Telegraf. Okay, now let's jump right in. First, let's take a look at our workflow diagram and the key components we'll be using today. We start with the OPC UA simulation server. It's an awesome tool for simulating OPC UA data. It is great for developing and testing client applications because it lets us simulate various sensor data, device status, and the other real-time information, all without needing real physical devices. Next, we have Telegraf. This is a super versatile open source server. It's tailor-made for collecting, processing, and sending data from all kinds of sources. It is stable in monitoring and metrics collection, connecting with multiple data storage, message queues, and visualization tools. Telegraf has tons of input plugins for pulling data from places like database and APIs. It supports output plugins that can push data to the end, like CnosDB and CalCaf. By pairing the OPC UA simulation server with Telegraf, we can feed simulated IoT data straight into the CnosDB, which really beefs up the data support for our applications. Alright, let's start the OPC UA simulation server. Over the Status tab, you'll see a few key details. Server status show that if the server is up and running. PubSub status tell you if the publish subscribe feature is active. Connection address is where the server listens for client's connections. Current server time is the current server time. Server starting time is when the server's first kickoff. In this Object tab, you can manage instances of objects like sensors or actuators, thinking about adding, editing, or deleting. The Types tab is where you define the structure and the behavior of these objects. In OPC UA, types can range from basic ones like integers to customer structure or enums. The Namespace tabs give each object and type a unique identifier to keep things organized. Now, let's set up some entities in the Object tab to simulate some device data. We click the plugs icon on the top left to create a folder and name it Simulation Quality to track air quality devices. Confirm that, and then, with simulation quality selected, click the plus again to create a variable and name it temperature. This simulates air temperature data. Next, choose random for value types. Set a minimum value at 23 and a max value at 25. There you have it, a simulated temperature sensor cracking out real-time data. Next, we do the same thing to add a humidity sensor. Okay, with this sensor ready, it's time for Telegraf to step in and send this data to CnosDB. Let's open the Telegraf config file. Name is the table's name. Endpoint is the simulator's TCP address. Nodes are the two objects for temperature and humidity. In the Outputs HTTP section, set up the CnosDB details. We start the Telegraf give it a few seconds to start, and then you can see that the CnosDB console on the right. You also see a new table named Air Quality filling up with data from our sensors. Here, we wrap up our session today. And just to let you know, CnosDB Cloud is on live now, so feel free to join us for a free trial at CnosDB Cloud, or just hop right into our Discord group to chat more about it. Thanks for watching today, and I'll see you next time.